I'm Dr. Ludsmary, Associate Professor in the Department of Computer Science and Engineering. I'm going to take the topic Cloud Infrastructure Architecture Design of Compute and Storage Cloud for the subject Cloud Computing. So cloud infrastructure, so the architecture design is divided into three types: generic cloud architecture design, layered cloud development, and the virtualization support and disaster recovery. Architecture design of compute and storage cloud. The design goals are reliability, scalability, virtualization, and efficiency. So first we will see what is system reliability. Cloud scalability to meet the customer demand. Reliability to ensure that your products and services are as expected. Cloud availability to ensure that customers can access your cloud services whenever they need to. They are in their demand. So bring all together to achieve high availability. So employee measures that make your computer cloud system more reliable ensures that three things: redundant resources kick in automatically when the system experiences a fault. There is no downtime and products and services remain available. Employees keep doing their jobs without knowing that something went wrong. Scalability, and so as in simple terms, scalability is, it can be extended to any number of systems. So cloud computing scalability refers to how well your system can react and adapt to changing demands. As your company grows, you want to be able to seamlessly add resources without losing quality of service or interruptions. As demand on your resources decreases, you want to be able to quickly and efficiently download your system so you don't continue to pay for resources you don't need. Virtualization is a technology that you can use to create virtual representation of servers, storage, networks, and other physical machines. So virtualization is the process of or the creation of virtual rather than actual version of something such as servers, desktop, storage device, and operating system or network resources. Or in simple words, virtual software mimics the functions of physical hardware to run multiple virtual machines simultaneously on a single physical machine. So virtualization is a technique which allows to share a single physical instance of a resource or an application among multiple customers and organizations. It does by assigning a logical name to a physical storage and providing a pointer to that physical resource when planned. So it's a creation of a virtual machine over an existing operating system, and hardware is known as hardware virtualization. So machine on which the virtual machine is going to create is called as host machine. From where it's going to create a virtual machine, that is called a host machine. Virtual machine is referred to as host machine. So the next term we are going to consider is efficiency. Cloud efficiency varies depending upon the business needs, but the ultimate goal is to make use of the cloud resources while minimizing the cost. So the selecting the right mix of people, processes, and technology which helps to lower the total cost of ownership. So what are the business need? Business need the freedom to initiate, analyze, and address any issues before they arise to maintain a secure environment in which assets, data, and the network are safely guarded. Efficiency, to assign resources on demand as required, including the powering down of physical servers automatically. So virtual servers, desktop clients, and telephony, which saves energy. End users can use instead of thick clients, they can use thin clients for the telephone activity, creating more energy efficiency. Virtual system reduces energy consumption along with saving energy on cooling system. So next, cloud architecture and layers. So we'll have the user SAS, software developer uses PAS, system admin uses IAS, application layer. So from the diagram it is clear that I will be using all the social medias, YouTube, platform, social framework, Amazon, simple Google app engine, infrastructure, storage and virtual machine, Amazon web services, flexi scale, rack space. Data center layer will be having CPU, bandwidth, disk and memory, which will comes under data centers. We'll see in detail. Platform layer is the operating system and application software that makes the layer. Users can able to rely on the platform. So what are the properties that cloud will provide? Scalability, dependability, and security protection. So it will give the users a space to create their apps, test the operational processes, and keep track of execution outcomes and performance. SaaS application implementations, application layer foundation. The objective of this layer is to deploy applications directly on machine. So operating system and application framework make up the platform layer, which is built upon the infrastructure layer. So by the way of illustration, Google App Engine functions the platform layer, which will use to provide API application programming interface, so support for implementing storage, databases, and business logic of ordinary applications. Infrastructure layer. Infrastructure layer is a layer of virtualization where the physical resources are divided into a collection of virtual resources. So using the virtualization technologies are Zen, KVM, and VMware. So this layer will be acting as a central hub of the cloud environment through which the client can able to communicate. So based upon which to create the platform layer. So the gives the user the flexibility. Automated resource provisioning is made available by virtualization, so which also improve the infrastructure management. So it sometimes referred to as virtualization layer. It's crucial for cloud computing since virtualization technologies are the only ones that can create many vital capabilities like dynamic resource assignment. Application layer, which is at the top of the stack, is where the actual cloud ops are located. Clouds are opposed to traditional application can take advantage of the automatic scaling functionality to gain greater performance, availability, and lower operational cost. It consists of different cloud services which are used by the cloud users. Users can access these applications according to their needs. They are divided into execution layer and application layer. Application layer is responsible for processing IP traffic handling protocols like Telnet and FTP. So other examples include web browsers, SNMP protocols, HTTP protocols, and HTTP successor protocols. So last layer is a data center layer, and this layer is responsible for managing physical resources such as servers, switches, routers, power supplies, and cooling systems. Providing end users with the services requires all resources to be available and managed in data center. Physical servers connect through high-speed devices such as routers and switches in data center. In software design, the division of business logic from the persistent data it manipulates is well established. The requirement for data to become service has arisen within the introduction of microservices. A single database used by microservices creates a very close coupling. A data layer containing many databases. So each and every one serving a single microservice. Virtualization is our last topic. So virtualization support with the disaster recovery. Virtualization, so we all know. Then how it is combined with a robust disaster recovery. Real data with disasters like a fire incident, abnormal long-lasting power outages, cyber security, these are not predictable. So virtualization is to depend upon the backup system and recovery plan before any unexpected disaster happen. In a virtual computing environment, your organization can gain its operating capacity even in unpredictable disaster like cyber security breaches or damaged hardware. So how to recover the data from the backup system, restarting application on different hardware instead of waiting to repair the old one. So we'll use the terms resilience. It improved operational efficiency and business continuity are essential. That might be the best time to invest in virtualization server. Thank you.